Welcome, virtual students. Here we go. We got a few radical problems to simplify. Number 1 says the square root of 27. On the screen, top of the screen. Here we go. Any perfect roots that are a factor of 27? Yes. The square root of 9 and the square root of 3. 9's a perfect root. I keep it underneath the radical sign. Square root of 9 is 3. What's the square root of 3? Some crazy decimal, and so I don't want to do anything with that, and I leave it as 3, radical 3. Show of hands, who got that one right? Okay, about half the class. Let's take a look at number 2. We've got 5 radical 3 times 4 radical 6. Treat the radicals just like you would a variable. So the 5 times the 4 is 20. And then the square root of 3 and the square root of 6 is the square root of 18. It stays underneath the radical sign. Now, normally we would be done right there. However, the square root of 18 can be simplified. Is it a perfect square? No. Is there a factor that goes into 18, which is a perfect square? Yes. The square root of 9 and the square root of 2. All right, now, the square root of 9 is a whole number. It's 3. The square root of 2 is not a whole number, so we keep it as the square root of 2. We can't just drop the 20 out in front. It's a multiplication problem. So 20 times 3 radical 2. Do I take the 20 times 2? No! That's not really 2. Remember, that's a decimal. Do I take the 20 times 3? Yes. And so we end up with 60 radical 2. Oh boy, show of hands. How many people got that one? 1, 2 people. Oh boy. All right, let's go to number 3. Now we've got a fraction of 5/8 underneath the radical. No good. No fractions allowed under the radical. So we have to separate it to the square root of 5 over the square root of 8. Now, at this point, there's actually a couple different ways we would go. What I would recommend is to multiply both the top and the bottom by the square root of 8, which is multiplying by 1. Remember that. That's okay mathematically. This is a value of 1. When I do that, I end up with the square root of 40 over 8. Remember, square root of 8 is 64. Square root of 64 is 8. So the shortcut is just saying that it's 8. Okay, are we done? No, we're close though. The square root of 40, does it have a perfect root that's a factor? It does. I'm running out of room on my paper here, but I think we can squeeze it in. The square root of 4 and the square root of 10 over 8. What's the square root of 4? 2. Radical 10 over 8. Now, can I reduce the 10 and the 8? No! The 10 isn't 10. The 10 is the square root of 10, which is like 3 point something, blah, 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 blah. But can I reduce the 2 and the 8? Yes, I can. And I end up with the square root of 10 over 4. And we are done. They got progressively more difficult. Who got number 3 right? Jacob. No? Okay. Like I said, we're going to be doing more and more of these as practice. We'll do it again tomorrow, probably on Wednesday as well. Just giving you more practice with radicals, how to simplify. Any questions? Now that I do it, do you understand it a little bit better? Okay, the more practice you get, the better off you'll be. All right, keep your notes out. Let's quickly review. We, on Friday, did 45, 45, 90 right triangle. All right, so what does that mean? Means that we've got a right triangle, which happens to be an isosceles triangle. I'm gonna go fairly fast, so stay with me. I know it's Monday morning and we lost an hour over the weekend. Stay with me. Okay, so that means that these sides are the same. Now it depends on which and what we're giving first. Let's say that we've been given the leg. Let's say that this is 6. If I know that that's 6, then I can safely conclude that this is 6 because they are the same. Isosceles right triangle. Now, the shortcut to go from a leg to the hypotenuse is over on the poster behind Keegan's head. And we multiply it by the square root of 2. And so we get 6 radical 2 for the hypotenuse. What do we do if we go from the hypotenuse to the leg? We divide by radical 2. Okay, that's the shortcut. It's really simple. Multiply by square root of 2 or divide by square root of 2. Any questions? That's review. We did that on Friday. We didn't do many sample problems, but that's what we did. Yeah? Good? Poff, you all right? All right, because now we're going to go into the next one. The next one's called the 30, 60, 90 right triangle. Remember, these all are considered special right triangles. So here's a right triangle. Here's my 30 degree. Here's my 60 degree. Now, I'm giving you that, but I do want to talk about this a little bit. Think through an angle with me with the third side. I think I can get this on the screen. If I think of this as an angle, you guys see the angle? Let me back out a little bit. Here's my vertex down here by my hand, right here. So there's my vertex, right? If I think of the other side being like that, when I open up the vertex or I make the angle larger, what can I conclude about the other side? As the angle gets larger, what happens to the other side? The side gets smaller? It gets longer. If I continue opening it up, right, look at that. How doesn't the other side logically just get longer, right? So if it's real narrow, if it's a really small angle, look at the length of that third side. That side. Do you see the connection? As the angle gets larger, the other side gets longer. Right? Okay, so with that being said, we know always opposite the 90-degree angle, that side is called the hypotenuse. Always. And it's always considered the longest side. Always. Always the longest side. Because it's across from the largest angle. Okay, if this is 60 degrees, then we've got a fancy name for this one. The long leg. It's the longer leg. Right? Because it's across from the larger angle. So it's a longer leg. There's no fancy name for it. That's it. Long leg. Okay? Yeah, I know. We get real creative here in geometry. If this is across from the 30-degree angle, guess what this one's called? The short leg. Really simple. So we got long leg and short leg and hypotenuse. That's it. Okay? Which one's the long leg? Across from the 60 degrees. Which one's the short leg? Across from the 30 degrees. Okay? Now, are we dealing with any other triangle other than 30, 60, 90? No. That's it. So we know that the three measures of the angles are 30, 60, 90. Now, in the future, you'll be dealing with right triangles that are not what we call special right triangles, which are these two. But for now, when we have this, we've got certain rules that are in play, okay? Let me use black here. If the short leg over here, let's say that it has a length of 3, okay? So if I know the short leg and I want to go to the hypotenuse, all I do is multiply by 2. And so then the hypotenuse has a length of 6. It is that simple. You go from the short leg to the hypotenuse. It's right above Keegan's head. Keegan, no, turn around. I want you to point at it. If you look at the poster, you see where it says A for the short leg? Up, 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 right there. A for the short leg. Everyone see that? Now, Keegan, go to the hypotenuse. What's it say? 2A. 2 times A. Everyone see it? Okay, so to go from the hypotenuse to the short leg, if I multiply by 2 to go that way, what am I going to do to go the other way? Divide by 2. Divide by 2. Everyone good? Okay. Now, to go from the short leg to the long leg, I multiply by the square root of 3. So I go from here to here, I get 3 radical 3. Multiply by radical 3. And then to go from the long leg back to the short leg, divide. Do you have to have these memorized? Not necessarily. Would it help you? Yes. Is that poster going to be up there the whole time? Yes. Look at Keegan again, if you don't mind, Keegan. Look at, turn around, look at the long leg, point at it. What is it? A. No, that's not, there you go. A radical 3. You take the short leg and you multiply it by radical 3. That makes sense. We good to go? Okay. So those are the rules. Let's take a look at what that means if we're looking at the angle. Okay, so let's say that I'm still got a 30, 60, 90 right triangle. We'll say that this is the 60, this is the 30, 90. So let's say that this is x, then this is x times 2. So we'll just call it 2x, and then this is x times the square root of 3. Everyone see that okay? All right, now, what if we go the sine of 30 degrees? What's its value? Well, we know from SOHCAHTOA, sine is opposite over hypotenuse. So if I start with 30 degrees, opposite is x. Hypotenuse is 2x. Everyone see that? Opposite the 30-degree angle is x over 2x. Reduce that. I can reduce the x's. What am I left with? 1/2. Everybody get your calculator out. Verify that the sine of 30 is 1/2. Better be 0.5. Just verify it on your own calculator. Profi, you good? Okay. Oh, I know. This is really challenging. What's the cosine of 60? Remember, those are complementary values. It better be 1/2. Well, you're not doing something right on your calculator. Cosine of 60 is 1/2. All right, let's go to the sine of 60. If this is right here, 60, that's x times radical 3 over 2x. The x's cancel. And so I'm left with the square root of 3 over 2. Verify it on your calculator. Find the decimal of the square root of 3 over 2, and then the sine of 60, they better be the same. I don't even know what the decimal is. What is it? 0.7? 0.8. Thank you, Gracie. Okay, cosine of 30 better be the same. Square root of 3 over 2. Go ahead and verify. Again, those are in the little chart there by Keegan's mug. Questions? Shayla, do you understand? Let's take a look at a couple examples, okay? Let's turn to page 716, number 6. Page 716, number 6. Everybody in your book, page 716, number 6. As you're opening, I'm going to recreate the diagram or the picture. There are 6 parts to a triangle, 3 angles and 3 sides. They already give us the 3 angles, 30, 60, 90. And they actually give us the long leg. 9 is the long leg. You can look in the book. You don't have to do it in your notes. Look in the book. 9 is the long leg. All right, if we're going from the long leg to the short leg, we always want to find the short leg first. There is no relationship between the long leg and the hypotenuse. There is no relationship between the long leg and the hypotenuse. So the long leg to the short leg, what do we have to do? Well, look at this. You may not remember, so take a look. Long leg to short leg, what do we got to do? Divide by radical 3. If you don't remember, look at the chart. Above Keegan's head. You see where it says A radical 3? And then go to A, what would you do? You divide by radical 3. Divide by radical 3. Divide by radical 3. All right, so let's do the math. 9 divided by radical 3. That's not simplified. How do we rationalize the denominator? We multiply by 1. Well, we're using square root of 3 over square root of 3 as 1. Right? But we're multiplying by 1. That's all we're doing. And so now we have 9 radical 3 over 3. Square root of 3, square root of 3, square root of 9. Square root of 9, 3. Does this 3 and this 3 reduce? No, that's not really 3. That's like 1 point. Blah, 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 blah. Okay? Gobbledygook. But can this 9 and this 3 reduce? Yeah. You know, I didn't say this last period, but I'm going to say it to you guys and for the people, the virtual. You want to use the radical as if it's a variable. Like if I had 9x over 3, that makes really easy, makes sense, right? The 9 and the 3 reduce. Does that make sense? 3x? Hi, Mr. Sackhouse.
Good morning.
Good morning.
How are we doing today?
Wonderful Monday.
Yeah, the sun came up, right?
That's right.
It was beautiful. Anybody see how red it was and orange? Beautiful. Without daylight savings time, we would have missed that.
That's right.
Quick question for you. The track meet that Erica and Brody are going to, do you know anything about it?
I don't.
Okay.
I don't.
You're good.
All right.
All right.
Okay, so we have 9 over 3 reduces to 3, and then the square root of 3. You just leave it like a variable. Some people, that clicks for people when they think about like that, how to simplify with the radical. Use it like a variable. Okay, that's it. That's the answer for the short leg. Let me put it in red here because we divided by radical 3. And so here we have 3 radical 3. Now, how can we find the hypotenuse? I'll put a question mark there. There's a couple ways. We could just put both parts into the Pythagorean theorem, or we could use the shortcut. If we know what the short leg is, and we want to go to the hypotenuse, anybody remember the shortcut? What do we need to do? Multiply by 2. It's actually really simple. We multiply by 2. So we take 3, radical 3, and we multiply by 2. And we get 6 radical 3. Here's our 2 answers. Okay? Now you can use the Pythagorean theorem. You're going to get the same thing. Okay? But the shortcut's easier. You just got to be careful with working with radicals because some people, when they take that multiply by 2, they think you got to multiply inside the radical by 2. Remember, that's not really 3. Again, think of it as if it's a variable. If this were 3x times 2, what would you get? You would get 6x. You want to treat it the same way. So you want to treat like this number 3 right here is like a coefficient. So the coefficient times 3 times 2, you can get 6. All right, questions on that? All right, now, so we've covered a lot. 45, 45, 90, 30, 60, 90. There's actually one other topic that they talk about in this section, which we have already discussed, but I'm going to quickly remind you. You remember what 3, 4, 5, what they are called? Okay, they are called Pythagorean triples. Remember, there are some common Pythagorean triples. Not just 3, 4, 5, but any multiple of 3, 4, 5. Yeah. 3, 4, 5 is 1. Here's another one. 5, 12, 13. Those are Pythagorean triples. 8, 15, 17. 7, 24, 25. Those are Pythagorean triples. Okay? And so the book refers to Pythagorean triples. Just know what they are, and you can use them on those questions. here's your assignment. It's on page 716. Let me clarify a couple things about this assignment. We're starting with number 1. We already did number 6. We're going all the way to number 18. All. However, this is due on Wednesday. So tomorrow in class, we're going to do some more of these examples. We're also going to review some more of the radicals. So we're not moving on between now or today and tomorrow. This is it. Okay? So take your time, work through it. 45, 45, 90, 30, 60, 90. Know the rules. If you got to go over and look at the poster, I'm good with that. Okay? Or make a cheat sheet right on your homework. I'm good with that. Okay? So you know the rules to go from leg to hypotenuse, hypotenuse to leg, blah, 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 blah. Questions? Juanita, you have a question? All right. I'm seeing you. All right. Okay, that's it. Thank you, virtual students.